From worldwideweb.++.com/doc/tutorial/. Part 05. A double quote, learn by listening double quote, exercise. Basic input-output. The example programs of the previous sections provided little interaction with the user, if any at all. They simply printed simple values on screen, but the standard library provides many additional ways to interact with the user via its input-output features. This section will present a short introduction to some of the most useful. C++ uses a convenient abstraction called double quote, streams double quote, to perform input and output operations in sequential media such as the screen, the keyboard, or a file. A stream is an entity that allows C++ logic to insert or extract characters. There is no need to know details about the media associated to the stream or any of its internal specifications. All we need to know is that streams are a source/destination of characters, and that these characters are provided/accepted sequentially, open parenthesis, i.e., one after another, close parenthesis. The standard library defines a handful of stream objects that can be used to access what are considered the standard sources and destinations of characters by the environment where the program runs. 4 of those streams have become so well-known as to be considered a standard part of any C++ program. They are 1 of 4, cin, standard input stream. 2 of 4, cout, standard output stream. 3 of 4, carr, standard error, open parenthesis, output, close parenthesis, stream. 4 of 4, clog, standard logging, open parenthesis, output, close parenthesis, stream. We are going to see in more detail only cout and cin, open parenthesis, the standard output and input streams, close parenthesis, semicolon, carr, and clog, are also output streams, so they essentially work like cout, with the only difference being that they identify streams for specific purposes, error messages and logging. In many cases, in most environment setups, they actually do the exact same thing, they print on screen, although they can also be individually redirected. Standard output, open parenthesis, cout, close parenthesis. On most program environments, the standard output by default is the screen, and the C++ stream object defined to access it is cout. For formatted output operations, cout is used together with the insertion operator, which is written as double left arrow, open parenthesis, i.e., to double quote, less than double quote, signs, close parenthesis, as shown in these 3 lines, Line 01 of 03, cout, double left arrow, double quote, output sentence double quote, semicolon, / prints output sentence on screen. Line 02 of 03, cout, double left arrow, 120, semicolon, / prints number 120 on screen. Line 03 of 03, cout, double left arrow, x, semicolon, / prints the value of x on screen. The double left arrow operator inserts the data that follows it into the stream that precedes it. In the examples above, it inserted the literal string output sentence, the number 120, and the value of variable x into the standard output stream cout. Notice that the sentence in the first statement is enclosed in double quotes, open parenthesis, double quote, close parenthesis, because it is a string literal, while in the last one, x is not. The double quoting is what makes the difference, semicolon. When the text is enclosed between double quotes, the text is printed literally, semicolon. When they are not, the text is interpreted as the identifier of a variable, and its value is printed instead. For example, these 2 lines have very different results, Line 01 of 02, cout, double left arrow, double quote, hello double quote, semicolon, / prints hello. Line 02 of 02, cout, double left arrow, hello, semicolon, / prints the content of variable hello. Multiple insertion operations, open parenthesis, double left arrow, close parenthesis, may be chained in a single statement, cout, double left arrow, double quote, is double quote, double left arrow, double quote, is a double quote, double left arrow, double quote, single C++ statement double quote, semicolon. This last statement would print the text double quote, this is a single C++ statement double quote. Chaining insertions is especially useful to mix literals and variables in a single statement, cout, double left arrow, double quote, I am double quote, double left arrow, age, double left arrow, double quote, years old, and my zip code is double quote, double left arrow, zip code, semicolon. Assuming the age variable contains the value 24 and the zip code variable contains 90,064, the output of the previous statement would be colon. I am 24 years old and my zip code is 90,064. What cout does not do automatically is add line breaks at the end, unless instructed to do so. For example, take the following two statements which make insertions into cout. Cout, double left arrow, double quote, this is a sentence. Double quote, semicolon, cout, double left arrow, double quote, this is another sentence. Double quote, semicolon. The output would be in a single line, without any line breaks in between. Something like colon. This is a sentence. This is another sentence. To insert a line break, a new dash line character can be inserted at the exact position where the line should be broken. In C++, a new dash line character can be specified as double quote, \n double quote, open parenthesis, i.e., a backslash character followed by a lowercase n, closed parenthesis. For example, consider these two lines. Line 0, 1 of 0, 2, cout, double left arrow, double quote, first sentence. New line, double quote, semicolon. Line 0, 2 of 0, 2, cout, double left arrow, double quote, second sentence. New line, third sentence, double quote, semicolon. This produces the following output, spanning across 3 lines of text, colon. First sentence, second sentence, third sentence. Alternatively, the double quote and double quote manipulator can also be used to break lines. For example, consider these two lines, colon. Line 0, 1 of 0, 2, cout, double left arrow, double quote, first sentence, double quote, double left arrow, and semicolon. Line 0, 2 of 0, 2, cout, double left arrow, double quote, second sentence, double quote, double left arrow, and semicolon. This would print the following output onto separate lines, colon. First sentence, second sentence. The ENDL manipulator produces a new line character, exactly as the insertion of single quote, \n, single quote, does, semicolon, but it also has an additional behavior, the stream's buffer, open parenthesis, if any, closed parenthesis, is flushed, which means that the output is requested to be physically written to the device, if it wasn't already. This affects mainly fully buffered streams, and cout is, open parenthesis, generally, closed parenthesis, not a fully buffered stream. Still, it is generally a good idea to use ENDL only when flushing the stream would be a feature and, single quote, new line, single quote, when it would not. Bear in mind that a flushing operation incurs a certain overhead, and on some devices it may produce a delay. Standard input, open parenthesis, cin, closed parenthesis. In most program environments, the standard input by default is the keyboard, and the C++ stream object defined to access it is cin. For formatted input operations, cin is used together with the extraction operator, which is written as double right arrow, open parenthesis, i.e., to double quote, greater than double quote, signs, closed parenthesis. This operator is then followed by the variable where the extracted data is stored. For example, look at these two lines, colon. Line 0, 1 of 0, 2, int age, semicolon. Line 0, 2 of 0, 2, cin, double right arrow age, semicolon. The first statement declares a variable of type int called age, and the second extracts from cin, a value to be stored in it. This operation makes the program wait for input from cin. Generally, this means that the program will wait for the user to enter some sequence with the keyboard. In this case, note that the characters introduced using the keyboard are only transmitted to the program when the enter, open parenthesis, or return, closed parenthesis, key is pressed. Once the statement with the extraction operation on cin is reached, the program will wait for as long as needed until some input is introduced. The extraction operation on cin uses the type of the variable after the double right arrow operator to determine how it interprets the characters read from the input, semicolon. If it is an integer, the format expected is a series of digits, if a string a sequence of characters, etc. Consider this 14 dash line example, colon. Line 0, 1 of 14 //a/o example. Line 0, 2 of 14. Line 03 of 14, pound sign, include open angle bracket, IOStream, close angle bracket. Line 04 of 14, using namespace STD semicolon. Line 05 of 14. Line 06 of 14, int main, open parenthesis, close parenthesis. Line 07 of 14, open curly brace. Line 08 of 14, int I, semicolon. Line 09 of 14, cout, double left arrow, double quote, please enter an integer value colon double quote, semicolon. Line 10 of 14, cin, double right arrow I, semicolon. Line 11 of 14, cout, double left arrow, double quote, the value you entered is double quote, double left arrow, I, semicolon. Line 12 of 14, cout, double left arrow, double quote, and its double A is double quote, double left arrow, I asterisk, 2, double left arrow, double quote, new line, double quote, semicolon. Line 13 of 14, return 0, semicolon. Line 14 of 14, close curly brace. Running this program yields the following output. Please enter an integer value colon 702. The value you entered is 702 and its double A is 1404. As you can see, extracting from cin seems to make the task of getting input from the standard input pretty simple and straightforward. But this method also has a big drawback. You might wonder what happens in the example above if the user enters something else that cannot be interpreted as an integer. Well, in this case, the extraction operation fails. And this, by default, lets the program continue without setting a value for variable I, producing undetermined results, if the value of I is used later. This is very poor program behavior. Most programs are expected to behave in an expected manner no matter what the user types, handling invalid values appropriately. Only very simple programs should rely on values extracted directly from cin, without further checking. A little later we will see how string strings can be used to have better control over user input. Extractions on cin can also be chained to request more than one datum in a single statement colon. Cin, double right arrow A double right arrow B, semicolon. This is equivalent to executing the following two distinct statements on two lines colon. Line 01 of 02 cin, double right arrow A. Line 02 of 02 cin, double right arrow B, semicolon. In both cases, the user is expected to introduce two values, one for variable A, and another for variable B. Any kind of space is used to separate two consecutive input operations, semicolon. This may either be a space, a tab, or a new dash, line character. Cin, and strings. The extraction operator can be used on cin to get strings of characters in the same way as with fundamental data types. Here are two lines of sample code that tell the compiler to prepare space for a character string to be named double quote, my string double quote, and to populate it with characters extracted from cin, colon. Line 01 of 02 string my string, semicolon. Line 02 of 02 cin, double right arrow my string, semicolon. However, cin, extraction always considers spaces, open parenthesis, white spaces, tabs, new dash, line, point, close parenthesis, as terminating the value being extracted, and thus extracting a string means to always extract a single word, not a phrase or an entire sentence. To get an entire line from cin, C++ designers have created a function called double quote, getLine, double quote, that takes the stream, open parenthesis, cin, as first argument, and the string variable, as second. For example, here's a 16-line program that asks for strings that can span across more than a single word colon. Line 01 of 16 / cin, with strings. Line 02 of 16, pound sign, include open angle bracket, IOStream, close angle bracket. Line 03 of 16, pound sign, include open angle bracket, string, close angle bracket. Line 04 of 16, using namespace std semicolon. Line 05 of 16. Line 06 of 16, int main, open parenthesis, close parenthesis. Line 07 of 16, open curly brace. Line 08 of 16, string my string, semicolon. Line 09 of 16, cout, double left arrow, double quote, please enter your name colon double quote, semicolon. Line 10 of 16, get line, open parenthesis, cn, comma, my string, close parenthesis, semicolon. Line 11 of 16, see out, double left arrow, double quote, hello double quote, double left arrow, my string, double left arrow, double quote, new line, double quote, semicolon. Line 12 of 16, see out, double left arrow, double quote, please enter the name of your favorite team colon double quote, semicolon. Line 13 of 16, get line, open parenthesis, cn, comma, my string, close parenthesis, semicolon. Line 14 of 16, see out, double left arrow, double quote, I like double quote, double left arrow, my string, double left arrow, double quote, 2, backslash n double quote, semicolon. Line 15 of 16, return 0, semicolon. Line 16 of 16, close curly brace. When this program runs and a typical user responds, the following output is generated. Please enter your name colon Homer Simpson. Hello Homer Simpson. Please enter the name of your favorite team colon the Isotopes. I like the Isotopes too. Notice how, in both calls to get line, we use the same string identifier, mstring. What the program does in the second call is simply replace the previous content with the new one that is introduced. The standard behavior that most users expect from a console program is that each time the program queries the user for input, the user types a response, and then presses enter, open parenthesis, or return, close parenthesis. That is to say, input is generally expected to happen in terms of lines on console programs, and this can be achieved by using getLine to obtain input from the user. Users frequently enter multiple words when prompted for input, even if the context implies a single word response. Therefore, unless you have a strong reason not to, you should always use getLine to get entire lines of input in your console programs, instead of extracting single words with cn. String. The standard header, open angle bracket, string, close angle bracket defines a type called double quote, string double quote, that allows a string to be treated as a virtual string device, and thus allowing extraction or insertion operations to and from strings in the same way as they are performed on cin and cout, as if a human operator had typed designated text into the stream. This feature is most useful to convert strings to numerical values and vice versa. For example, this 3-line code snippet can extract an integer from a string colon. Line 01 of 03 string my string, open parenthesis, double quote, 1204 double quote, close parenthesis, semicolon. Line 02 of 03 int my int, semicolon. Line 03 of 03 string, open parenthesis, my string, close parenthesis, double right arrow my int, semicolon. This declares a string named double quote, my string double quote, which is initialized to a text value of double quote, 1204 double quote. It also declares an integer variable named double quote, my int double quote. Then the third line uses this my int variable to extract from a string constructed from the string. As a result, the numerical value 1204 is stored in the integer variable called my int. Here is a full program, implemented with 21 lines of C++ code, showing these principles. It will ask a user for price and quantity data and then calculate a total. Line 01 of 21 / strings example. Line 02 of 21, $, include open angle bracket, IOStream, close angle bracket. Line 03 of 21, $, include open angle bracket, string, close angle bracket. Line 04 of 21, $, include open angle bracket, stream, close angle bracket. Line 05 of 21, using namespace std, semicolon. Line 06 of 21. Line 07 of 21, int main, open parenthesis, close parenthesis. Line 08 of 21, open curly brace. Line 09 of 21, string my string, semicolon. Line 10 of 21, float price equals 0, semicolon. Line 11 of 21, int quantity equals 0, semicolon. Line 12 of 21. Line 13 of 21, cout, double left arrow, double quote, enter price colon double quote, semicolon. Line 14 of 21, get line, open parenthesis, cn, my string, close parenthesis, semicolon. Line 15 of 21, string, open parenthesis, my string, close parenthesis, double right arrow price, semicolon. Line 16 of 21, cout, double left arrow, double quote, enter quantity colon double quote, semicolon. Line 17 of 21, get line, open parenthesis, cin, comma, my string, close parenthesis, semicolon. Line 18 of 21, string, open parenthesis, my string, close parenthesis, double right arrow quantity, semicolon. Line 19 of 21, cout, double left arrow, double quote, total price colon double quote, double left arrow, price asterisk, quantity, double left arrow, end all, semicolon. Line 20 of 21, return 0, semicolon. Line 21 of 21, close curly brace. Here is some sample output from this program, representing a purchase of 7 items at a price of 22.25 each. Enter price colon 22.25. Enter quantity colon 7. Total price colon 155.75. In this example, comma, we acquire numeric values from the standard input indirectly colon instead of extracting numeric values directly from cin, comma, we get lines from it into a string object that we have named double quote, my string double quote, and then we use cin to extract sequential values from this string into the variables double quote, price double quote, and double quote, quantity double quote, comma, as if the user had entered them each directly into cin on separate lines. Once these are numerical values, comma, arithmetic operations can be performed on them, comma, such as multiplying them to obtain a total price. With this approach of getting entire lines and extracting their contents, comma, we separate the process of getting user input from its interpretation as data, comma, allowing the input process to be what the user expects, comma, and at the same time gaining more control over the transformation of its content into useful data by the program.